Hi there, welcome to the Atmel Explained board. I've got one here showing on a webcam at the moment. As you can see, there's a little LED flashing here. There's also a little switch, a tact switch next to it. Nothing programmed into that at the moment. We're interested in this microcontroller in the middle of the board here. This is an Atmel AVR series Atmega 328P. It's the one we're interested in. There is a second microcontroller on the board, a little bit bigger one. That's a 32-bit type microcontroller, and that's used for handling the communication between the PC at the other end of this cable and this microcontroller. And we can do lots of interesting things, debug things with this. On the board you'll find a whole lot of connections that we can solder things to. What I've got I want to show you though is how to get this Hello World program into it and how to get it going. I've got the simulator I've built for the microcontroller. And on this web page you can see the simulator. We can drag devices into it and program them over here. I'm going to open up a slightly bigger version of this. Here we go. Now we can run our program or we can step through it line by line. Let's have a look at a program first. If you've never seen a program like this, it's pretty complex to start with. These darker areas, they're all comments. Now I put a lot of comments into my code. It makes it easy to understand later on. And I like to set up my code in a particular way. So I use these lines here to break the code up into different sections. I advise you not to change those inside the simulator because this code is automatically generated when you add new devices to the microcontroller. And if it can't find these lines, it won't know where to put the new code. Zoom this so we can see it. So this board here is a mock-up of this board here, but we don't have all the pins on it. We have the ones of interest. Down this side here there are 6 that we're really interested in that we can connect things to. And over here we've got a couple of rows, but we've got one line here which is B and D. Now these B, C and D things are called ports, P-O-R-T. So that's port B, port C and port D. Port B goes from 0 to 5 and the LED is connected to B5. B6 we can't use. It's not available to us, and it's the signal that comes from this microcontroller to this one to keep the timing accurately. It runs at 16 megahertz, that line. We can get it B7, but only if we use the switch. We can't actually connect anything to it. So this switch here is connected to B7. And that's why I've got this little switch looking thing here so that you can press this and make things happen in your program. Port D, you've actually got D0 to D7, and that's pretty common in a port that there are 8 pins from something 0 to something 7. Port C is a little bit different. We've only got 6 here. If you want to use a couple more of them, there are C6 and C7. Not really, but sort of connected here in the middle of the board, and you can use those later on for something special. But at the moment you've got 6 here, you've got 8 here, you've got 1, 2, 3, 4, 5, 6 here. Now just take careful note that there are 6, and there are 8, but you don't have a D.8 or a B.8. What you have is a D0 through to D7, a B0 through to B5. That's how you get your 6 pins. So in our program, as I was saying, I like to break it up into these sections. What we're going to do is look at the actual program itself, and that's this main thing. So a C program starts at main and then runs until it gets to an end or it gets stuck somewhere. So what our program is going to do is it's going to get stuck somewhere. Watch this. We'll step through these line by line, or when you're tired of stepping them, you can just run them. You can see these lines here are now running. It's stuck in this while one loop. So while one means, well, while whatever's inside these brackets is true, do whatever's inside the braces. So at the moment, the 1 is inside the brackets. So whatever's in the brackets is true. 1 is always true. So it's going to run whatever's in these braces forever. And that one there turns on the LED. This one waits a little bit. that turns off the LED, and this waits a little bit. And over here, you can see the LED flashing. Let's just step now, put it into step mode. So at the moment, the LED is on. It's doing a little wait here. Step again. When the line completes, the LED turns off, and then it does a little wait. So we can run that a little bit faster if we want to, or we can run a little bit slower so we can see what's going on. Now I want to stop this for a moment, and you'll see the code here will change. Okay, the code changed. What happened is this command here, set LED 0, and this command CLR, clear LED 0, that's what turns the LED on and off. But they're not the actual program commands to turn the LED on and off. We've defined set LED 0 as a macro for this line of code here. So this is the actual line of code which is running. And so when I go to step, it comes down here and it replaces this line of code with the actual line of code. And that's the use of a macro. So why would we use set LED 0 in a program rather than port B and the rest of this code here? Well, it's a lot easier to read. And so in your program, you'll find that it's a lot easier to use macros for hardware things. It's much easier to toggle an LED off with this command, or on back, and then than it is with this command. And you'll learn about what these commands mean later on. So let's run that code. Now I've got it running reasonably slow step at the moment. We can slow it right down if we want to. It takes about 2 seconds for each thing. Or we can speed it up to a bit more of a reasonable speed and watch it go through. So just follow those blue areas on the screen to see what it's doing. And at the end of each line, it completes the command. So a main program, just stop that. A main program starts here, has this opening brace and a closing brace down the end. It's got some things to do with our hardware, and then it's got an actual while loop, which means run forever. And that's a unique thing about embedded systems that are different to other computer systems, is that they run forever. Now, I'm going to stop this here, and in the next video I'm going to show you how to put this program into the microcontroller board itself.